Well, good morning, everyone. I think there's still a few people signing on, but I'd like to welcome everybody here. This morning we have astrophysicist Dr. Jennifer Wiseman with us to speak on science and a universe of awe. The title just went away. Awe, challenge, and possibility. I want to welcome you here on behalf of Boston Fellows and on behalf of the Octet Collaborative, the two organizations that are hosting today's event. Boston Fellows is a 9-month program for professionals seeking to cultivate the insights and spiritual habits necessary for meaningful vocation within a cohort of peers, spiritual leaders, and professional mentors throughout the local church. And I've had the pleasure of serving as a cohort facilitator for several years. I also serve as the director of the Octet Collaborative, which is a new Christian study center serving MIT. We're working to build a community of students, faculty, and staff at MIT dedicated to human flourishing as formed by the historic Christian faith. And so both Boston Fellows and the Octet Collaborative are thrilled to have Dr. Wiseman with us today. Dr. Wiseman, it's good to see you. Hello.
Thank you. It's nice to be here. Yes.
In just a minute, I'm going to hand things over to a friend of mine and yours, and I believe a former colleague of yours, John Zahone, to introduce you. Before I do that, let me just give a few brief housekeeping details before we kick things off today. In the chat, you will see some information being posted for you. You'll see today's schedule, so you'll see that Dr. Wiseman is going to give us 2 roughly half-hour talks. After each of those is going to be about 15 minutes of Q&A. I will moderate that, so I'll provide the questions. But if you have questions for Dr. Wiseman, please put those in the chat, and you can do that at any point. We will monitor those, and I will do my best to get to as many of those questions as I can in the time that we have. In between the talks, we're going to have some time in breakout groups so that all of you get to interact with each other. And those actually will be led by members of the Boston Fellows STEM cohort. Several of those are with us today. To make it easy to divide us up into groups, if you wouldn't mind renaming yourself with your first and last name, and in the chat are instructions for how to do that. The last thing for me to say, just by way of housekeeping, is if you wouldn't mind, please mute your audio during the talks so that we can cut down on background noise. Up to you what you want to do with your video. Just to let you know, this is being recorded, so keep that in mind for your audio and your video. I think with that, I will hand things over to John to introduce us to Dr. Wiseman. Thanks very much.
Nathan, pleased to introduce today Dr. Jennifer Wiseman, who's an astrophysicist, author, and speaker. She studies the process of star and planet formation in our galaxy using radio, optical, and infrared telescopes. She's also interested in national science policy and public science engagement. She served as a Congressional Science Fellow for the American Physical Society and directs the program of dialogue on science, ethics, and religion, also known as DOZER, for the American Association for the Advancement of Science, the AAAS. Dr. Wiseman studied physics at MIT, co-discovering comet Wiseman-Skiff in 1987, and continued in astronomy with her doctoral research at Harvard. So she's very well acquainted with Boston. She has worked with several international observatories and is currently a senior astrophysicist at the Goddard Space Flight Center. Dr. Wiseman is a fellow of the American Scientific Affiliation, a network of Christians in science. She frequently gives public talks on the excitement of scientific discovery. And she grew up on an Arkansas farm, enjoying late night stargazing walks with her parents and pets. Just a personal note, I worked in a different area of astronomy. I had an office on the same floor as Dr. Wiseman at Goddard Space Flight Center. And occasionally I'd see her office and I'd, pop my head in and we'd have a friendly chat. And it was always a good time and always a highlight of my time at Goddard. And I should also say that she's been a a wonderful impromptu organizer for the Christians in astronomy who are to get together for lunches at our biennial American Astronomical Society meeting, which is also a treat. So with that, welcome Jennifer, and looking forward to hear your talk today.
Okay, I am just, this is so fun, and I'm so happy to be able to join you today. And it's also interesting to me that I have connections, as John just said, both we were working near each other at Goddard Space Flight Center, but I lived in the Boston area for many years as an undergraduate at MIT studying physics, and then as a graduate student at Harvard University studying astronomy and astrophysics, just living in that whole area for more than a decade. I have an affinity to the place. So, but it's interesting that I can kind of interact with you right now, even though I'm not physically there, but I kind of wish I was able to be with you in person in the Boston area. But I know that many of you are joining today from who knows where because of the virtual situation that we are in. And that's very good. So I'm going to give two presentations today. The first one is to get us thinking about science and discovery and technology in general. And what that implies for our lives, for society, what the latest discoveries and advances in science and technology are doing for us or may do in a positive sense, and what challenges they bring, ethical challenges or challenges of how we should use this technology. And some types of technology can bring good, some can bring harm, some bring both, depending on how we use them. Now, some of you may be involved professionally in science and technology related fields, as I am, and some of you may not. That may not be your profession. You may not even think that science has much to do with you, but actually science and technology are affecting all of us, no matter what our professions and jobs are. So I hope this exploration will open our minds to how this is relevant to our lives and the callings that we have on our lives. The second talk that I plan to give later this morning is about, more specifically, about what we're discovering in the universe and what it might mean for our view of ourselves as humans. So, so I hope you enjoy both of those. And the moment of truth is about to come, where we see whether my sharing screen will actually work. This, speaking of science and technology. So here we go. I'm going to see if this will work. Did it work? Okay. All right, so here's the kind of grandiose title that somehow in the next half hour we're going to discuss science and a universe of awe, challenge, and possibility. And of course, as I understand it, after my talk, there'll be discussion time, both with me, and then I think you're going to be breaking up into small groups to discuss some of the implications of what I am sharing today. Okay, so let's get started. What you see behind in this cover slide is actually an image of stars. And I'll say a little bit more about that. I think I have another picture of that, but we live in an amazing universe. Stars are plentiful. There are hundreds of billions of them in our Milky Way galaxy alone, and they are continuing to form. And the big ones are continuing to die off when they run out of fuel. So star lives, if you will, are active. This is a region where stars have recently formed, recently in cosmic time, and they form out of interstellar gas. And so this cluster of stars here is lighting up the leftover surrounding gas and the nebula around it, and it just shows you the kind of beauty and activity of these regions. That's me with a model of a telescope that I work with, the Hubble Space Telescope, and an image taken by such a telescope in the background there, the Whirlpool Galaxy. I should say that this morning I'm not representing any of my professional organizations I work with. I'm giving my personal reflections this morning. And I didn't grow up actually thinking that I would become a professional scientist. I didn't know any scientists. I didn't grow up in an area near a university. I grew up in the rural part of northern Arkansas in the Ozarks. So that's me with my nearest neighbors when I was growing up uh, on a little family farm. And my parents were not even able to go to college, but they really appreciated the idea of education. So they made sure that their kids could go. And I grew up wandering around meadows and forests. That's me there, bundled up on a very cold January day on the farm. But I grew up able to wander the farm and really think about nature and just explore streams and nearby lakes and rivers and forests and meadows and see wildlife. I love animals. And I love the sky. On clear nights, we could see lots of stars when I was growing up outside. And it made me curious about what it would be like to be able to explore space, maybe go into space. At the time I was growing up, also the first images from the Voyager probes that were passing nearby solar system planets and sending back images of their exotic moons for the first time we were getting. And I was just fascinated by this, and I still am. And I wanted to be a part of that enterprise of space exploration. I didn't know how to do that, but I was curious about nature. And science fiction movies like Star Wars and all that were first coming out during those years I was growing up also. So we were all kind of thinking about space. But I didn't know how to be involved in space exploration. I just knew I was kind of curious about it. And science is a wonderful way of studying the natural world. So I think I had a kind of natural affinity for science and related mathematics, things like that. But that wasn't the only thing I was interested in. I was interested in music and literature and other things too. Fortunately, I was able to go on to university with some courage and studied physics, which is a basic science that enabled me to keep my options open, and also went on then to graduate school to study astronomy and astrophysics. I had a lot to learn because I didn't kind of grow up with my own telescope or anything like that. And I'm thankful that people, even though what I did was kind of unusual for people from my rural uh, schools and environment, but people from my family church and my own family and teachers and so forth were encouraging for me and others to go ahead and go for it. Try things that are unusual or out of the box, and we'll support you. And so I was glad I was able to do that. So now, years later, by God's grace, I had opportunities to learn how to do science, become a scientist, work with scientists. And I am now working in the field of astronomy and science oversight. In astronomy, we use different kinds of tools to study the heavens now. We use telescopes on the ground, telescopes in space. The image here just shows you some examples. The top image is of the Hubble Space Telescope, which is the most well-known space telescope. It's in orbit around the Earth right now, and it's still in wonderful shape after 31 years of operation, thanks to a lot of maintenance on it over the years. It's above Earth's atmosphere, so that's why it can get some very clear images of deep space. But we also need telescopes on the ground. The lower left telescopes there are on the top of a mountain in Hawaii. The Keck telescopes. The lower right shows you an example of radio telescopes in South America. This is the ALMA millimeter and submillimeter wavelength array of telescopes. All of these different types of tools, they see different types of light. They give us different types of information. So we use them together to think about or to learn about whatever we're trying to study in space, whether that's planets or galaxies or stars or even the interstellar medium. So the technology opens doors for understanding and exploration. There's the telescope again. In this case, that telescope was put into orbit by the Space Shuttle. Astronauts have returned several times to do upkeep on the telescope. And so here's an example where engineering and science and government oversight has and taxpayers and public support. And all of these things have come together to enable this mission to exist and to thrive and to give us all worldwide understanding of the heavens. Here's the last astronaut mission up to the Hubble when the space shuttle was still flying. And they put in new instruments and repaired some of the older instruments, leaving the telescope in excellent condition right now. So I'm thankful for that. One of the astronauts that went up on the space shuttle for that last servicing mission we did with the shuttle back in 2009 brought with him something quite interesting. So here's an image from the cockpit of the space shuttle. You can look through the window there and see the Hubble Space Telescope. So at that moment, they were docked together, orbiting around the Earth, so that for several days, the astronauts could go out of the pressurized space shuttle for little excursions in their spacesuits to do maintenance work on the telescope, and then they would come back into the space shuttle. What you see in front there is what astronaut John Grunsfeld brought with him, which is a model of Galileo's telescope. So Galileo is the first person we know who used a telescope to look at the heavens and make recorded observations of what he saw, kind of scientific records of observing things such as Jupiter and its moons. And his observations of the solar system really confirmed the Copernican idea that the sun was in the center of our solar system and bodies orbited around the sun, and even some bodies like moons orbited other bodies like that. So it was a wonderful advance. And since then, in those about 400 years since Galileo's time and the Hubble Space Telescope time, the technology has just taken off and been improved over the centuries, enabling us to see things and understand things about the natural world that we never would have been able to before. So let me make sure that, yeah. So this is a way of seeing our universe in a way that our natural eyes could not see. And here's another beautiful image taken with the Hubble Space Telescope of a cluster of stars that have formed out of interstellar gas. When little pockets of gas become dense enough, they will collapse under their own gravitational pull. And if there's enough matter, the pressure inside that little clump of gas will be enormous, igniting fusion of hydrogen atoms and through a series of reaction, creating heavier atoms and releasing light. So stars are little factories, and the bigger ones can ionize, which means it lights up the surrounding gas in this, such as in this region, which is, I think, very beautiful. And so we're finding out that we live in an incredible universe that inspires wonder and awe. Here's an image of stars taken also with the Hubble telescope. This was just a test image for the newest camera that was put on the telescope. And if you're above Earth's atmosphere, you do get that sharp resolution because the light isn't getting blurred or filtered out by the turbulence in our own Earth's atmosphere. And you can see that stars in this dense cluster are plentiful. They are also different from one another. When I'm giving a public lecture, I often ask people to point out differences in stars and in this image, and they point out, of course, that they're different colors and different brightnesses, different sizes. So this is the core of a cluster known as Omega Centauri, and from this image alone, you can see that star differs from star in splendor. In fact, that's a Bible verse. If you can find that, you get extra credit at the end of the session today. They look like gemstones to me, but you can't really say much about the context and yet unless you use a different kind of telescope. So here is an image from the ground looking at the broad swath of sky, much wider field of view than the Hubble telescope sees, and toward the center of our galaxy, where you can see lots of dust and gas, lots of stars. And in this context, as we zoom in on one of those bright objects, we'll see that it's not actually a single star. So we're going to zoom in to one of these objects in the Centaurus constellation, and then transition over to the Hubble Space Telescope image that sees more detail. So you can now see that that object was actually a whole cluster of stars. And there again is the core of that cluster that the Hubble telescope sees. And so context tells us a lot more than if we just see isolated pieces of information. And that's true in many facets of life. Okay, I'm going to move on here. Galaxies here can contain hundreds of billions of stars, as well as lots of gas and dust, all held together by gravity, lots of unseen dark matter. This is an example galaxy. It contains probably hundreds of billions of stars, so many that in the core that it just blends together in a bright glow, and it's quite beautiful. And we now know that there are lots of galaxies. Immanuel Kant, philosopher, said that two things filled his mind with ever increasing wonder and awe, the more often and more intensely he reflected on them. And those two things were the starry heavens above him and the moral law within him. And I think that's so interesting because even today, I think humanity is reflecting on these two realms of things, the natural world, the universe large, and also in the very small levels of nature. And where did we come from? How do we relate to the natural world? And the moral law within us. How do we know there's a moral law? Everyone seems to feel like there's such a thing as justice and right and wrong, although in different cultures that manifests itself in different ways. But even C.S. Lewis, who was not a Christian believer as a young adult, but he began to wrestle with the idea that, you know, everybody has a sense of right and wrong. Everybody has a sense of justice. Where does that come from? And that was a realization on his path to personal faith and conversion to faith in Jesus Christ, and realization that there is a moral law within us that we're vaguely aware of and often violate. Okay, that's a kind of backdrop from the astronomical perspective, but I want to broaden out to other kinds of science and technology. New technologies are in fact enabling new scientific discoveries and advances, such as I am talking about in astronomy, and we'll talk more about in my second talk this morning. But these new scientific discoveries and advances, the new scientific understanding ends up spawning new questions about life and about humanity and how we use this technology and what does it mean to be human in this natural world we're learning more about. And it brings new depth to old questions. So the questions of humanity spur the development of new technologies and exploration. And then those new technologies and new discoveries turn around and spawn new and deeper questions in that kind of cycle. And in fact, science and technology are impacting nearly everything about our life today in both philosophical and very practical ways. So here's just a list. It's not a comprehensive list, but think about it. Everything that we interact with is being affected by science and technology. Our food production, agriculture, communication, our environment, and of course, changes in the environment, climate change, health. And of course, we're all thinking about pandemics and viruses and how they spread and how we address them right now. Space exploration, education, animals, how we understand animals, and how do we interact with them? Are they peers? Are they food? Are they lab equipment? Do they have rights and needs? What about national defenses around the world? And the influence of science and technology on art and literature and history, of course, for good and ill. And all of this is intertwining as we're becoming more and more aware with social justice issues and injustice issues intertwining with all of these impacts of science and technology on our society worldwide. So what are some examples of this? I'm just going to run through a few here. There's no way I can be comprehensive, but in your discussions, you can think of more. So think of these examples of discoveries and advances and how they affect our view of ourselves as what it means to be human and what we do with this kind of knowledge. Let's start and end with astronomy, of course, because that's my field. For one, we're discovering now a lot of planets outside of our solar system. We didn't know of any when I was in early graduate school. We know about the planets orbiting the sun. We suspected there might be planets orbiting other stars, but we didn't have the technology to actually see them or find out. And now, within the last few decades, the technology has improved, and we've detected thousands of planets. And so we can start addressing the questions that humanity has had for millennia. Are there other planets in the universe besides the ones near our sun? The answer to that we know is yes. Is there another Earth-like planet out there and potentially life? We're well on the way to addressing that question, but we don't know the answer to that one yet. Greek philosophers were imagining this thousands of years ago, that there were other worlds like and unlike this world of ours. There's an artist's conception of a very real system that has been discovered with the Kepler Space Telescope of a star with a tight orbiting system of 6 planets. We call these exoplanets. They're planets outside of our solar system. So what does it mean that we're finding all these planets and potentially habitable planets outside of our solar system? Does that change our view of the uniqueness of Earth and humanity? And I'll say more about that in the next lecture. All right, different topic. What about the human body, the human microbiome? It turns out that we now understand that our bodies are not just single entities, that we have trillions of microbiota cohabiting within our body. We have at least the number of cells in our body that do not have our DNA, because they're basically different organisms than cells that have our DNA. And so we're realizing that we are, in fact, little walking ecosystems. And in fact, we would not survive if we did not have these other organisms within our body interacting. And so this is affecting both our view of what it means to be a human. Am I an individual, or am I a little walking community? And it also affects us in practical ways as we think of uses of drugs and how they impact our microbiome, also nutrition around the world, and how our microbiome affects our mental health and all kinds of things. So that's another hot topic. All right, another hot topic: the interface between what we would call humans and what we would call machines is actually blurring. I mean, you know that already if you're staring at your phone and your smartphone and your computer this morning. already, even a decade ago, we're starting to realize that humans and machines were beginning to merge as we talk about actually uh, uh, implanting things in the human body to help us function better, or building artificial intelligence that rivals the way humans think, and may in fact um, affect how humanity lives and thrives. Um, Artificial intelligence has both great promise and great challenge for ethical uses of this technology. And here's an example of some serious thought by Nathan Matthias on Christians for AI and its relationship to society, for special thought for Christians. And so I encourage you to look up his writings, and there's some examples down there about what we think about AI relating to global cooperation, artificial persons, and what about how that relates to fairness and sin and religious freedom and justice and consciousness. These are all thoughts that really need to be taken seriously. We're having to teach machines perhaps to make ethical decisions, such as the conundrum of if a self-driving car happens to see a group of people, but if it swerves to miss those people, it will in fact hit one person and presumably kill them. So at what point is it ethically better for the car to swerve with the chance that it will actually kill someone, versus not swerving when it might harm several others? And how do you teach a machine to make those kinds of judgments? We're learning a lot about neuroscience and the brain, and when is the brain actually alive and dead? There were brain waves detected from a pig a couple of years ago that everyone thought the animal was in fact dead, and then the brain revived. So deciding when someone is actually dead or alive is not always a clear-cut decision. And then another realm where technology is really interacting with human life is the health of the planet itself, tomorrow's Earth, and how we take care of the planet itself, and the climate and its habitability is being impacted by how we are using technology now and the choices we're making now. All right, more questions. Neuroscience. Am I only my brain? Am I basically defined by how my brain is working and the health of my brain? Or what about genetics? Am I only my genes? Should we, and am I completely defined by my genetic makeup, or does my environment affect who I am? And then again, these ethical questions. We can now edit genes through CRISPR technology. Should we be doing that? We can actually perhaps obliterate some terrible diseases by editing genes. That's a wonderful blessing. But we can also alter humanity, especially if we edit genes in a way that gets passed down the gene line. Some really profound ethical problems here. Technologies are in fact transforming biology. And Francis Collins, the director of the National Institutes of Health, himself a committed Christian, usually pretty calm-natured, but when some researchers from China actually edited the genes of a pair of twins with the intention of helping them to avoid contracting HIV. But Francis Collins said that this little experiment, since we don't know the ultimate impact of editing genes, was profoundly unfortunate, ill-considered, an epic scientific misadventure that flouted international ethical norms with utterly unconvincing justifications. So we have ethical challenges as the technology is speeding way ahead of the rate in which people around the world can consider how to ethically put boundaries on what kinds of technology we develop and use. All right, I put a couple of more here. Artificial intelligence, I've already touched on, and then how all of this weaves into social justice, and how science itself and the way it's done can be used in very unethical ways. We think of the Tuskegee experiments, of course, as one of the prime examples of very unethical way of doing scientific research. But even today, we're realizing that what's being put, of course, in the codes of artificial intelligence, of our computers, of software, of things that are behind the way our businesses run, the way even healthcare runs, are often laced with the presumptions of those, of course, who humans who designed these things. That and in fact, racial inequities, injustices, and presumptions can be perhaps unintentionally, but wound into the way coding is done, and the way the software and different types of decisional algorithms are written, which end up creating unjust results in society. So I recommend you read and watch the presentations and read the books of Dr. Ruha Benjamin, who's been exposing some of this flawed logic that's behind much of our computational and AI work going on, and what we can do to address that. Environmentalism is something that needs to be thought about in the context of larger values. And so here is a conservative Christian writer talking about how being an environmentalist should not be something that's disparate from being someone who's a deep person of faith. All right, and then I see that I am running out of time here. So let me just go back and give you a preview that the whole universe is developing and changing. So back to something I'll talk about in the next talk. Anyway, there's a lot of questions where science interacts with these bigger questions of who we are as humans and how we should be using the technology and the scientific advances in ways going forward, because how we understand ourselves as humans scientifically and how we use technology can have great good or great ill impacts on life going forward, not only for us, but for other creatures on this planet. And these are some examples of questions at the interface of science and the bigger questions of life. And it turns out that science, of course, cannot answer and address all the questions of life. Science, it answers very certain kinds of questions, but not the bigger questions of why. Why do we exist, and how should we live? Is there a God? How do we relate to one another and to God in the most fruitful ways? Can science and theology come to complementary conclusions, answering different kinds of questions? I believe so. And today's challenges and opportunities are interconnected more than ever before. Science is not, one little subject you take in school that's different from everything else. No, it's all intertwined. Studies of the brain and behavior relate to not only science, but studies of health and even the law. Are we responsible for our behavior if we're just acting out what our brains tell us to do? What about artificial intelligence? That involves education, law, business, technology. Space exploration involves engineering, business, policy, international relations, of course. And environmental challenges involve science, policy, business, education, and the law. And business has international scope and impact involving the environment and, of course, international finances. So all of these things are intertwined, and they all have ethical and moral implications. All right, I'm going to skip past the universe one because we'll talk about that next lecture. But just to say that science and these other ways of looking at the world, including theology, are concerned with the search for truth. And so Dr. John Polkinghorne, who recently passed away, was a physicist and also an Anglican priest. he did wonderful writings about the relationship of science and religion. And he said that science and theology complement each other rather than contrast each other. They focus on different dimensions of truth, but they share this common conviction that there is truth to be sought. And I think that's something to reflect on. We're all searching for truth and how to use that truth in interacting ways. I'm going to skip this to mention that for Christians, we believe that not only does God care about the universe, but that God has actually experienced, as we do, life in the universe through what we call the incarnation, where Jesus Christ himself walked in the flesh and has offering eternal and abundant life. He said, I've come that we may have life and have it to the full. And how we use science and technology speaks to how we live life and enable others to live life in a flourishing manner as well. All right. So how do we respond to all of this? I think we should be giving praise for the universe, maybe feeling a sense of humility and awe. And we need to, I think, be good stewards caring for our planet and all of its inhabitants, including the animals. There's an ethical stewardship call here. And I think exploration and learning is also something that's warranted by the discoveries we've already made. And that can be uplifting to the human spirit. So I'm going to skip through some of this for the next lecture, pointing out that there's a lot of resources here if you want to dig deeper into this. I'll show this slide on the next lecture too. So with that, let me just end by this image looking back on our planet Earth from the space shuttle. As you see the sun rise there behind planet Earth, and you see this very wispy view of Earth's atmosphere. That blue arc there is our fragile and beautiful atmosphere of planet Earth. And I hope that inspires us to think about the beauty of our own planet and our need to be good stewards of it and all its inhabitants, using the scientific knowledge and technological advances that we have. And I'm going to leave that presentation right now and hand the mic over to our sponsor here. Thanks for your attention so far.
Yeah, Jennifer, thank you so much. I want to thank you in particular for the first 10 or 15 minutes of that presentation, just the awe,
We'll do more of that in the next talk too.
Yeah, that's fantastic. Let me just remind everybody, put questions for Dr. Wiseman into the chat. We've got a couple so far. So while those are being gathered, let me start you with a question that jumps off of one of the last things that you talked about, which was the idea of science and faith being complementary to each other. I know that in my conversations as a pastor with scientists, they have often said that experience can be rare. In theory, it makes sense that science and our faith should complement each other. I wonder if you could take us to a moment in your career when you saw that happening. Can you give us an example of a time that your faith and your work as an astrophysicist just came together and complemented each other?
Sure. There's kind of two levels of answering that question. So let me kind of back a little bit and just first answer kind of more objectively that, and we can talk about this also in the next lecture too, but if our faith, and now I'm speaking personally as a Christian here, if our faith means anything, it means that it's relevant. And right now, the relevancy in science and technology has never been more real than it is as we think about vaccines and addressing a pandemic around the world and finding the technology to address it, and then and then making this technology available and desirable for people around the world. That involves not only the science, but it involves policy, it involves relationships, it involves cultures. And so science, and for Christians, this involves loving people. I mean, we don't often hear the word love in the same phrase as science, but a part of love is service and helping people, and we can help and serve others better if we're using the best knowledge that we have. And I would say that God has enabled us to have through science and technology. So of course, both in philosophical and in practical ways, for Christian faith to be relevant, it needs to be embracing the science, the scientific knowledge, and understanding how that meshes with our understanding of God and creation and our place in it, our value, and how we serve and love one another. So that's the practical interface of these things. Now, personally, I find looking at the universe just incredibly humbling, almost fear inspiring. And I'll say a bit more about that when I show some images of the deep universe in the next talk. Because it's just unfathomable to me as I think about how many galaxies they are, and over kind of unfathomable time that these galaxies have taken on characteristics that now enable us to have life on at least one planet. I can't think about time. My brain doesn't. I can say the numbers, but I can't actually contemplate. And yet there seems to have been a directionality, and I would even say a purpose in it all. And that to me kind of gives me the chills in a personal sense. But I will say what actually personally inspires me the most is when I give talks to people who perhaps are not working directly in fields of science, and they, for the first time, maybe see images of galaxies or star-forming nebulae, or think about exotic things like black holes and dark matter. Think about planets like Earth, and even the diversity of life that we already know of on planet Earth, and how that diversity might extend beyond planet Earth. And to see that sense of wonder and excitement and curiosity, bringing together people from different cultures around the world to unite them, to unite us in that sense of amazement and maybe a shared calling to explore for good purposes, not just for selfish gain, but for curiosity and for lifting the human spirit. That to me is when it all comes together, that there's a reason for exploration, and it's to bless other people. And there's a reason for doing science. The good reason ought to be to help others and to lift up our spirits, for Christians to deepen our understanding of God and our reverence, and to serve and love one another. And when I see that kind of coming together, that's when I have a real sense of joy.
Yeah, that's great. There's so much there. Thank you. Let me ask. I'm going to go to a couple of the questions that have come in so far. So you mentioned points in your career when you've been involved in the oversight of science. So somebody asked, what do you think is the single most challenging question currently facing those charged with oversight in science?
Well, oversight is a broad word, so that can mean overseeing a particular scientific project, a single endeavor. It can also mean overseeing perhaps federal grants programs that go into funding science research across the country or internationally. It can mean people thinking about science policy at the highest levels of how does our nation and other nations decide what kinds of science to fund, and how it should be used. The policies that govern science and technology are forever changing because science itself changes so rapidly. I think right now, for example, in space exploration, there's a lot of commercial uses of space that are rapidly advancing. Should there be any national or international policies governing that? For example, thousands of satellites are being put into orbit around the Earth, and they're creating a light pollution situation that's blinding the sky in some ways for certain types of astronomy. Is that okay? You know, should there be policies put in place? So, so I think science oversight involves wisdom and needs wisdom as to what are we doing and why, and what are the driving values for using the science and technology we have. Is it simply for commercial gain? Is it for benefit, and benefit of whom? Is science only benefiting a certain swath of humanity? That's part of the justice issue with science right now, is that not everyone has been equally welcomed into the enterprises of science and technology, and not everyone has benefited equally from the results coming out. So where are the justice issues? Policy and oversight come into that. So there's the big challenges of asking the right questions of how and why we're doing science, how and why we're supporting it. And then there's the kind of mundane questions that I often have to face, of just simple budgets and schedules and those kinds of things, and how we treat one another in these scientific environments, how we open doors of opportunity, and once people are involved, how we're using different different experiences, different backgrounds, different perspectives to make sure that we're governing the uses of our scientific and technological programs in the best possible ways, using diverse perspectives to guide us.
And since you're talking today to an audience that's a mix of people who are working in the sciences and those that aren't, and presumably the kind of oversight that you're talking about in the broad sense requires cooperation and communication of scientists and non-scientists, the general
Sure.
public, the policymakers, you know. Are there any, do you have any thoughts on kind of the first steps, some of the things that scientists and non-scientists should be doing to engage one another, to be able to communicate about, you know, these topics that are complicated both technically but also ethically? Any ways you'd like to see a coming together?
Oh, yes, because I think we all tend to work in our little siloed environments. And that was what I was trying to point out in that one slide I showed, of how all these things are interrelated now. Scientific discoveries are funded by, in some cases, the government funded work is funded by taxpayers. Industry related work is funded by the industry, of course, and commercial and business interests. But how do we develop best practices and ethical practices for deciding what we do and deciding how we as humanity does it? Well, you need to have interactions. You need to proactively reach out of your comfort zone and talk to people in other fields. We need people in business to be talking about people who are working in um, international NGOs, who in communities and countries where the impacts of certain business practices are being felt in the day-to-day lived environment of people in other cultures and places. We need crosstalk. We need talk about, as one of the examples I mentioned, is private industry has, for no ill purposes, has moved right ahead with building and continuing to plan to build constellations of thousands of satellites to improve internet connectivity for people around the world, which is a noble endeavor in some sense. But these satellites are now really in danger of making some of our most sensitive telescopes, especially the ones that survey large swaths of the sky, uh, basically ruined, because no exposure from that telescope can go on without one of these satellites crossing its path. Did we really mean to blind the night sky by, in that sense, and curtail our exploration of the universe, sometimes with telescopes that have taken years and millions, if not billions of dollars to put together, because some other facet of society has developed another technology that conflicts. There should have been crosstalk ahead of time, about these aspirations of humanity that might have conflicting outcomes, but might not need to if there is enough crosstalk. We need to have um, people who are developing agricultural advances talking to local farmers in communities where big ag is actually interfering with the culture of small communities, and of course with the welfare of animals and the health of people worldwide, while big ag might also make the case that they are helping feed a growing population. So we do need crosstalk in various ways, and I bet everybody on this meeting today, regardless of what your profession and your interest is, can think of ways how reaching out of your particular silo of expertise to some other area, especially when it involves the uses of science and technology, could be beneficial. And many people have gone into science policy related work because they are interested in that big picture. I myself became, after 6 years of postdoctoral research in astrophysics, I became a little bit oh, I don't know, I was a little bored, actually, a little disillusioned with just very narrow research. And I applaud people who can focus their whole careers on some very narrow questions of research because it's important. But my brain is more like spaghetti. I try to think about how things interrelate. I wanted to know the bigger questions, and I started prayerfully looking around for other opportunities because I was kind of discouraged in my career path. And I was able at that time to become what's called a Congressional Science Fellow. And so for a year and a half, I worked on Capitol Hill in a very different environment from the research fields I had been accustomed to. I worked for the Science Committee of the US House of Representatives, and they didn't want to know about my detailed astrophysics, but they did care about kind of my broad understanding of how science works. And I was able to learn about how our legislative branch thinks about science, and um, puts and how they have to balance the just the pure science facts that scientists really focus on with the needs of their constituents and the economic needs of their districts and the international implications of certain sciences that we support or don't support. And kind of getting that bigger picture was helpful for me, and hopefully helpful for my colleagues there, as I also input the perspective of a scientist. There are science policy positions throughout the federal government, including the executive branch, where people can spend a year or two coming out of a science career, becoming a policy fellow, working at a different agencies, even the White House Office of Science and Technology Policy, and then either go back to the career they came from, or some choose to stay for permanent careers. So there are ways from the science perspective to actually become more aware and involved of these bigger policy questions. And for those of you who are in other fields, business, law, there are ways also, or you can create ways of building crosstalk and understanding, because science and technology is intertwining with every aspect of human endeavor these days, and we need to do the crosstalk. Otherwise, we go down paths that actually create harm rather than good.
Excellent. Thank you.